Creating common denominators to add and subtract fractions. This is a review lesson that I put in the middle of chapter 2, just to help you with the concepts that will come next. So common denominators, before fractions can be added or subtracted, they must have common denominators. We find common denominators of two or more fractions by using the least common multiple of the denominators. A multiple, remember, is the product of a number multiplied by an integer. So for example, 12 is a multiple of 3 because 3 times 4 is 12. So here's some practice finding common denominators. In this example, we are doing 2/3 plus 3/5. So in step 1, you are to list the multiples of each denominator until you find a match or the least common multiple. So we have 3 and 5. So I'm going to do 3 times 1 equals 3. 5 times 1 equals 5. 3 times 2 equals 6. 5 times 2 equals 10. 3 times 3 equals 9. 5 times 3 equals 15. 3 times 4 equals 12. 5 times 4 is 20. And 3 times 5 equals 15. Well, I see now that I have a match. I have 3 times 5 equals 15, and 5 times 3 equals 15. So the least common multiple of 3 and 5 equals 15. So in step 2, I have to convert my fractions to have the denominator of the least common multiple using multiplication. So my least common multiple was 15. So I need to convert 2/3 into something over 15 and 3/5 into something over 15. I'm going to use multiplication, and remember, whatever I multiply the denominator by, I have to multiply the numerator by as well. So 3 times 5 equals 15. So I have to do the same to the top. 2 times 5 is 10. And then 5 times 3 equals 15. So I have to multiply the numerator by 3 as well. And 3 times 3 is 9. So now I have 10/15 plus 9/15. Now in step 3, I'm simply going to add or subtract my numerators. So again, I had 10/15 plus 9/15. So 10 plus 9 equals 19. And I keep my denominator the same as 15th. So I wouldn't leave this fraction as improper. So I would use, remember, long division to turn it back into a mixed number. I would do 19 divided by 15. 15 goes into 19 one time. 1 times 15 is 15. I subtract. I have nothing left to bring down, so my answer is 1 remainder 4, which transitions into 1 and 4/15. So your answer in mixed number form would be like that. I'll honestly accept either mixed number or improper fractions for these problems. So let's do another example here, 7/8 plus 3/12. In step 1, I'm going to list my multiples of 8 and 12 until I find a match. So 8 times 1 equals 8. 12 times 1 equals 12. 8 times 2 equals 16. 12 times 2 equals 24. 8 times 3 equals 24. So I've already found a match. I have a least common multiple of 24. So in step 2, I'm now going to convert both of my fractions into having that denominator of 24. So 7/8, 8 times 3 is 24. So 7 times 3 is 21. So 7/8 is equivalent to 21 over 24. And 3/12, I would have to multiply both my numerator and denominator by 2. So 3/12 is equivalent to 6/24. And now in step 3, I can just add 21/24 plus 6 24ths equals 27 24ths. And if I were going to convert that back into a mixed number, I would do long division. So I would have 1 3 24ths, which actually simplifies down into 1 1/8, because the greatest common factor of 24 and 3 is 3. So that's where I get the 1/8 from. So we can try one with subtraction. 9/10 minus 5/6. Again, I need to find my least common multiples. So 10 times 1 is 10. 6 times 1 is 6. 10 times 2 is 20. 6 times 2 is 12. 10 times 3 is 30. 6 times 3 is 18. No math yet, so I keep going. 10 times 4 is 40. 6 times 4 equals 24. 10 times 5 equals 50. And 6 times 5 equals 30. Well, now I have a match of my least common multiple of 30. So 9/10 equals how many 30ths? Well, I'm multiplying by 3 in my numerator and denominator. So 9/10 is equivalent to 27 30ths. And 5/6 is equivalent to how many 30ths? Well, 6 times 5 equals 30. So 5/6 is equivalent to 25 30ths. And now step 3, I'm simply going to subtract my numerators. 27 30ths minus 25 30ths equals 2 30ths. These are both even numbers, so I'm going to divide by the greatest common factor, which is 2. And my final answer would be 1/15. So I hope you found this refresher lesson useful. You're going to need to use it in the next 2 lessons when adding and subtracting rational numbers.